I've been voted Teacher of the Year more than 5 times at my colleges and universities. And I can give those skills over to you by watching today on High Peak Education. So we're looking at greatest common factor. So the basic idea is that we're going backwards from multiplying things out in algebra. We want to look at several terms and see what is common to all of them. We sort of do this in a little bit 2 ways. When we look at numbers, we look to see what number is a common factor. In other words, what numbers are both the coefficients divisible by. And then when it comes to variables, we think about powers. So if I have 3 terms, one of which is x to the 5th, one of which is x to the 3rd, one of which is x squared is going to be the greatest common factor. That's the largest power of that variable that all 3 of those terms would share. All right, so let's get into this in some detail. When we identify the greatest common factor, GCF, factor out the GCF from a polynomial's terms, and thus factor polynomials also by grouping. Find the GCF of the numbers 24, 56, and 64. What's probably a good way to be sure that we dissect these numbers, 24, 56, and 64, such that we're sure we get the greatest common factor? So they're all even, so we can divide 24 by 2 and we get what number?
12.
So can we keep dividing it down? 6 and 2. And then what about 2's done? It's prime, but what about 6?
2 and 3.
Now notice, this diagram that I just created is sometimes called a prime factorization tree. It shows you the factors or the roots. Let's do the same idea for 56. 56 breaks down into, well, it's even, right? So it's 2 and 28, but then 28 breaks down into 2 and 14, and then 14 is 7 and 2. Last but not least, let's do 64.
Could we do this time 4 and 16, or does it have
4 and yeah, no, it could be 2 and 32, it could be 4 and 16. It doesn't matter how you start.
Well, yeah, that's going to be 2, 2, and 16 is going to be like 4, 4.
And then that's going to be a bunch of 2's. One important way to think about the greatest common factor is that it is the largest shared number amongst all the numbers. If I use the highlighter here and I focus on the word shared, I could say, okay, let's look at 24, 56, and 64 separately. I notice that 24 has 2, 2, 2, and 3. I notice 56 has 2, 2, 2, and 7. I notice 64 has 2, 2, 2, 2, 2, 2. So the question is, what trio is actually shared amongst all these numbers? Yeah, in fact, 3 2's. Do you see that? 2, 2, and 2. A trio of 2's. Now, a trio of 2's is really just 2 raised to what power?
8.
So 8 would be the GCF. And let's think about how we know this. 24 divided by 8 is 3. 56 divided by 8 is 7. 64 divided by 8 is 8. But do the numbers 3, 7, and 8, do they have any common factors amongst each other? No. So the reason I bring that to your attention is what's left over should not have any shared factors. That's how you know you found the greatest common factor. Here's something to think about in terms of finding the GCF of a list of monomials. So monomials, individual terms. Find the GCF of the coefficients. So this is consider factors of the front numbers. And then find the GCF of the variable factors. So that's the largest power on each variable. Remember, the key word is shared, right? And then the product of those is the GCF. So when we think about the numbers 20, -4, and 12, what's the largest factor of those? It could be 2, but what number can we think of that goes into both 20, 4, and 12 evenly? Yeah, it's 4. So let's think about why this is. 20 times 4 is 5. 4 times 1 is 4. And then 4 times 3 is 12. But 5, 1, and 3 are all prime numbers that essentially are not shared. I'm thinking that we can just say the greatest common factor of the coefficients is 4. How about y's? Y raised to the second. Yes, that's it. And that's your answer. Let's start with the numbers. What should be the greatest common factor of 32, 8, and 24? I think it's 8, because 8 goes into both, and then x to what power? And then y to the, also y to the first, because we need the smallest, yeah. I mean, this would just be 8xy, right? Most professors would just write 8xy because anything to the first, it's understood.